Happy Monday. I hope you guys are having a great day. Welcome to two-way frequency tables. This is our last statistics topic. After this, we'll be getting ready to take our test. So let's get to it. A two-way frequency table. A two-way frequency table is pretty much what the name sounds like. It allows us to compare the frequencies or number of occurrences, frequencies, of two sets of categorical data in a population. So population just refers to a group, whether that's people or students or whatever people are measuring. Categorical data refers to data that's split up into exactly what it sounds like, categories or smaller subgroups. So maybe within a larger group, what is a subgroup there? So we're going to look at a few examples, break down some sample questions so that when it comes time for your practice, you'll be ready to go. So example 1, swimmers and runners were surveyed about their participation in other activities. This table shows how many swimmers and runners also participate in another activity. We're going to use the table to answer the following questions. So the first thing we should do is fill in the remainder of the table. We can see each row here. This row is swimmers, the other row is runners. And then it breaks down by whether they participate in another activity or not, no other activity. So we've got the same group of people, a mix of swimmers and runners, but we've got two pieces of information: what sport they participate and whether they do another activity or they don't. So we're going to calculate the row totals simply by adding up all the swimmers who participate in another activity plus the ones who don't. So 58 plus 10 makes a total of 68. For the runners, we add 66 plus 18 and we get 84. So there are 68 swimmers and 84 runners. We can also calculate the column totals. So between the swimmers and runners, how many participate in some other activity? 58 plus 66, with your calculator, that's 124. Of those who participate in no other activity, 10 plus 18, that's 28. So that means of the whole group surveyed, 124 of them do participate in some other activity regardless of their first activity, and 28 participate in no other activity. Now, that leaves one blank here. And it turns out this will be our, basically some people call this the grand total, because it's both the row totals and the column totals put together. We're basically saying that of the same group of people, we can split it two different ways, but we should both add up to the same number. So we can check 68 plus 84 makes 152, which is the same thing as 124 plus 28. So we're not double counting. We're either going to choose the row total or the column totals, but we can use them to check one another. So we've got a full two-way frequency table here, and now we can use it to answer some questions. So question A, how many swimmers were surveyed? So that would be our total number of swimmers, which we just established was 68. So 68 swimmers total. How many athletes participate in another activity? Well, luckily, we've got that total right here, 124 athletes. The question, how many athletes do not participate in another activity? Okay, that's the next total, the column total for no other activity, that's 28. And how many total athletes were surveyed? So our grand total is both the athlete types together, or both the activity types together, is 152 athletes. How many runners do not participate in another activity? So now we're splitting this up and we're saying, okay, there's basically two pieces of information. So first we're talking about runners. So we're just going to look in the runners row. And then we're saying the ones who do not participate in another activity. So that is 18 people total. So we're ignoring the swimmers for just a second. We're saying of all the runners, how many do not participate in another activity? Now question F, says, what proportion of all the swimmers and runners also participate in another activity? So a proportion, if you'll remember from middle school, is a fraction. It says, hint, use your answer from parts B and D. So what we're looking for here is we're trying to figure out if it says all the swimmers and runners, so we want all the swimmers and runners, and that's what we're going to use to divide by the number who participate in an other activity. So basically what we're saying is 124 out of 152 athletes. That's how we would say that as a phrase, but mathematically as a proportion, it looks like that fraction 124 divided by 152. Some people will choose to simplify this fraction. Personally, I think that it's okay to leave it in the unsimplified form because we get these numbers directly from our table. We're not going to lose any points for not simplifying it there, but just a heads up, some people will simplify it. But the long story short is we said how many other athletes, so they participate in another activity, and it's all out of all the swimmers and runners. Now the next two questions, G and H, you'll notice they use the word percent. So this is one step further. We're still going to talk about proportions here, but in our end result, we're going to have a percent. So looking at part G first, it says what percent of all the swimmers and runners, so that's our total number of athletes, also participate in another activity. So it's the same question, basically from part F, but now we're turning it into a percent in the end. So we take our number who participate, in an other activity, number of other, and divide it by our total, our all athletes together, which we decided was 124 divided by 152. And if we put that in our calculator, we get 0.352. Now, when we convert decimals to a percentage, remember we move the decimal place to the right 2 places. So this turns into the percentage 35.2%. Whoops, if I said 0.2, I should probably include it, 0.2%. So what this is saying of all the swimmers and runners, so of the 152 people who were surveyed, 32% of them participate in another activity. And you know what? Now that I'm looking at that number, I'm not sure that that's quite right. 35.2%. Let me double check that. You're probably looking at your calculator, hopefully, saying, what is she talking about? That's totally wrong. Oops. Looks like I divided by the wrong number. My mistake. Hopefully, that's an easy fix there if I can get my eraser to work. You should have gotten 0.816 if we're rounding correctly, 816, which is not 35.2%. No, it's 81.6%. So, my mistake, but let that be a lesson. You actually have to divide by the right number. Ah, you see what I did? This is not 176, it's just 76. So, in this case, the simplifying might have actually hurt me there. There you go, lesson learned. All right, now that we've got our mistakes out of the way, let's do number H, or option H for real this time. So this one says, what percent of the runners do not participate in another activity? So let's break this down. It says, what percent of the runners? So in this case, we're ignoring the swimmers, we're ignoring the total, we're just saying of the runners. And we want to know which ones do not participate in another activity. So, there are how many runners? That's the first thing we need to know. There are 84 runners, and 18 of them do not participate in another activity. So we're going to be dividing the runners with no other activity divided by the total number of runners, which turns out to be, we just noticed there were 18 runners with no other activity out of 84 runners. So this would be the proportion, but we're converting that to a decimal. So we're going to do this one correctly this time. And in our calculator, when we do that division, we get 0.124, which converts to the percentage 21.4%. So that means of the runners, ignoring the swimmers, just the runners, 21.4 of them do not participate, or 21.4% of them, excuse me, do not participate in another activity. So the long story short with our two-way frequency tables is we're taking one group, but we're considering two different pieces of information about them. And when we combine it that way, we get a lot of different perspectives, a lot of different ways that we can break down the information. And so the tricky part, I think, most frequently is making sure that we read the questions correctly. So as we get into example 2, I'm going to ask you a couple times to pause and actually try this out for yourself and then restart the video to check it. So let's start the example together. It shows how many voters voted to support an ordinance that bans smoking in public. And so we're going to use the table to answer the following questions. So the first step, it says compute the marginal totals and the grand total. So those are the row and column totals, and of course the grand total that we talked about in example 1. So right now, I think you should pause the video to fill in this table and check back in once you've got it done. All right, welcome back. Hopefully you've got that table all sorted out. I'm going to fill in my totals. So the voters 60 and older, there are 450 if I add 122 plus 328. For the voters 18 to 59, 414 plus 73 makes 487. And when I add both of these numbers together, I get a grand total of 937. Now, of course, I'm going to check that against my other totals here. So the number of people who voted for the ordinance, 122 plus 414 is 536. And the total number of people who voted against, 328 plus 73 is 401. So double checking here, I'm just going to make sure 536 plus 401 adds up to 937. Good, my totals match. So if your tables and your totals also match, I suggest right now pausing the video and trying questions B through I and checking back in the video to make sure you've got it. Welcome back. So let's make sure we've got this. Hopefully you did this on your own and now you're checking. How many voters were surveyed altogether? Well, that's another way of saying our grand total here, which is 937 voters. How many people voted for the ordinance? I'm going to use the total from my voted for column. That's 536 people. And how many people voted against? That's the next column. That's 401 people total of all ages. What percent of voters voted for the ordinance? So that would be the for folks divided by the total, the grand total here, which is 536 divided by 937, which as a decimal, and I'm going to do this right this time, is 0.572, which makes 57.2%. Now, we're not going to lose points if we're just going with whole number percentages, but we should at least make sure that we're always rounding correctly if that's going to be our strategy. Question F, what percent of voters voted against? So this is I'm taking the against, if I can spell that with the G. Against, divided by the total. when you're doing this, always make sure you're taking the smaller number divided by the larger number. That way we get a decimal that will turn into a percent. So this is 401 divided by 937, which is the decimal 0.428, aka 42.8%, not 42.8 people, but 42.8%. Part G, what percent of voters aged 18 to 59 voted for the ordinance? So now we're kind of breaking it into the subgroups. We're just focusing on one age group and one type of voter in that age group. So we need to know how many of the 18 to 59 were for the ordinance, and we need to know the total number of 18 to 59-year-olds. So the 18 to 59-year-olds who were for, there were 414 out of 487. So again, that would be my proportion, 414 out of 487, but we're using our calculator and division to convert that to a decimal, 0.850 if we're rounding, which is 85%. Part H, what percent of voters aged 60 and older voted for the ordinance? So now we're looking at how many 60 and older voted for, divided by the total number of people who are 60 and older. So again, we're kind of ignoring the other row. We're just focusing on that 60 and older. So there were 122 out of 450. So that's the proportion we're going to start with. 122 divided by, what did I say there, 450, which is 0.271 or 27.1%. Now, question I, you might have thought at first glance that it was the same question as question G. It says, what percent of people who voted for the ordinance were aged 18 to 59? So you might be asking, aren't we talking about the same group? But notice how it starts. It says, what percent of people who voted for the ordinance? Part G started with what percent of voters in that age group. So here we're kind of flipping it a little bit. We're thinking about within the people who voted for. So we're actually focusing on this whole column of the people who voted for, what percent of them were in this age group. So we're like I said, we're flipping this just a little bit. So we're thinking of 414 out of the 536 people who voted for. So what that breaks down to is we could think of it as the 18 to 59-year-olds who are for this divided by the total number who are for. So I believe I said that was 414 divided by 536. In our calculators, we get 0.772. Why am I putting that over there? That's 77.2%. So it's a different number than part G because it's a different question. It's a different way, it's a different perspective of the data. In part G, we were thinking about just within that age group. So that age group, how many people, what percentage voted for. In question I, we're looking at the people who voted for the ordinance. So we're taking a different perspective of the data and we get a different outcome. So last example on here, example 3 says, see if you can fill in the missing information in the following two-way frequency table. So the missing values are not just the totals this time, but we also have, we're looking at a population of boys and girls that are also considering the question whether they always wear glasses, whether they sometimes wear glasses, or whether they never wear glasses. So I encourage you to pause the video now and try to fill in this table and check back in when you're done. Welcome back. So hopefully by now your table's all filled in. As we go through this, I think that there are a lot of different ways, a lot of different places you could start with this table. So the way that I fill in the table may not be the same way that you approached it, and that's okay as long as we get the same things. That's the best part about frequency tables. So I'm going to start with some simple addition. I like 40 plus 36, so I can fill in this total. There are 76 people who always wear glasses. Now, I don't know how many boys sometimes wear glasses, so I can't quite fill this one in yet. I can't quite fill in this one in yet either. But the never wears glasses, 161 plus 144 is 305. I could also fill in my row total for the number of girls. 36 plus 55 plus 144 is 235 girls total. Now, like I said, there's a number of different ways we could do this. Even from right here, there's a couple different ways we can do this. So to fill in the number of boys in the group, I know that it's the total minus the number of girls. So 484 minus the number of girls, 235, which equals 249 boys. Now I still have a couple missing values here. So I'm going to focus on filling in the number of boys who sometimes wear glasses. I know that there's 200. I now know that there's 249 boys total, and 40 of them always wear glasses. 61 of them never wear glasses. So if I take 249, subtract 40, and subtract 161, the number I get should be my missing number of boys who sometimes wear glasses. That number looks like it is 48. So I've got that piece of information, and now I can add up. 48 plus 55 gives me 103 people, boys and girls, who sometimes wear glasses. Now, I filled this in, and I might be asking myself, did I do this correctly? So there's a couple of different ways we could check, one of them being, do my other totals now match up? 76 plus 103 plus 305 is in fact 484, so I'm good there. So just double checking that all of your totals match up in both directions is always a good idea. From here, if you needed an additional challenge, you could ask yourself some questions like, what percent of the students always wear glasses? What percent are boys who never wear glasses? There's a bunch of different ways we could break down this data. So if you're up for the challenge, I'll leave that to you. Otherwise, now you can show your completed notes to your guest teacher and pick up a copy of the practice. The practice is due on Wednesday, but I'm pretty sure you've got everything you need to have it done before we start class tomorrow. So good luck, have a great day, and I'll see you tomorrow.